So, what is the IB, first of all? The IB is a rigorous, academically challenging and balanced program of education designed to prepare students aged 16 to 19 for success at university and life beyond. Exactly the same as the Leaving Cert. So I think we all match up perfectly there. Just to give you a bit of background how the IB works, there are 6 different subject groups. So every student, there's a first language, second language, humanities. The sciences form part of group 4. There's maths, there's the arts and the options. It's a holistic program in terms of that the students will take 6 subjects. They'll take 1 from each of the groups. They'll take 3 at higher level, which are 240 hours. So the IB higher level have a greater depth of study than Leaving Cert, but the standard level have a lesser depth of study than the Leaving Cert. And that they're both worth the same points. So effectively you're taking 3 advanced subjects and 3 not so advanced. The students choose those throughout 5th year to start of 6th year, which ones they want to take at higher level. I'm not going to go into this, but this is the full structure of the IB. It's on our school website. It gives the idea of the holistic program. At the center of it all is this IB learner profile, and this is the idea of everything coming together. Everything is based around what we have called thinking and learning skills. These are the skills you want students to achieve throughout the program. The first one is their thinking skills, communication skills, social skills, self-management, and research skills. All of these we have far more description of on the school website. So if you want to go to the St. Andrews College website, you'll find these here. The teaching skills is what we're doing. We're basing everything on inquiry, focus on conceptual understanding. We're developing in both local and global contexts. We're focusing on effective teamwork and collaboration. We're differentiating work to meet the needs of all learners, and we're informing by both formative and summative assessment. Again, there's nothing different from this to I think what we get in our Leaving Cert and our senior cycle going on there as well. What we're talking about is how they actually bring in new programs. And where the IB is a bit different now is every syllabus is on a 7-year cycle. So it doesn't matter how good, how bad, what's going on, every 7 years is a new syllabus. And that's to ensure that each is fit for the purpose in a changing world and incorporates the latest educational research and lessons learned through a thorough evaluation of the existing curriculum. How do they actually go about their curriculum review? Well, the first thing I want to show is actually what does this mean in schools. This is actually what's happening in our school at the moment here. And the majority of our students do Leaving Cert, by the way. We have 30 students each doing IB in 5th year and IB in 6th year. We've got then another, in each year group, 150 doing Leaving Cert. So the majority do Leaving Cert, a small cohort do the IB. They're not just international students, they're actually now more and more Irish students doing it. As you see, as a school, we're used to actually having changing curriculum, and all IB schools are, because this is constant, and this is every 7-year cycle going on. The science review, we have a new science syllabus coming up in 22-23. There's an awful lot on this screen, but the key date is 22-23, we have a new science syllabus coming in. So what's happening to bring that in at the moment? And that's in its current part of the cycle there. So our 2nd year is basically we'll have that new syllabus. There's 3 phases to curriculum review and change in the IB. The first one is the evaluation phase. And they're basically, this is starting from year 1 of the new syllabus. They're evaluating it before it's even had its first exam. Reports from senior examiners, external consultants, survey. They do a lot of surveying of teachers. Our voice is very much required and actually very much listened to in the IB, which is hugely important as well and comforting. There's literature reviews going on in the world. They compare all syllabi around the world, and they also get feedback from universities who effectively have to have a accreditation sign-off whether they like the program or not. And that's quite important because if the universities are not happy with the program, they're not going to basically say, oh yeah, come on, because they have to have their international standards as well. So they have to be comfortable in what's going on in a global program. Their challenge is they're not developing for one country, they're developing for all the countries. And it's now pretty much in most countries of the world. Phase 2 is development phase. And again, they're meetings with teachers, examiners, consultants from all 3 regions. The IB is 3 different global regions. A lot of feedback through teacher surveys. So again, we as teachers are asked to give our feedback. We're requested to go in these committees. There's feedback from the review committees. They try the new assessment tasking criteria and they communicate to schools. So every year we get a report on where the IB curriculum are going. So in every development, we're now report 3. We now have more information what's happening, and that's discussed, and we can feedback and say we don't like that. Implementation phase, production of new materials, upskilling of workshop leaders, subject-specific seminars, and accreditation recognition. The aims of a course, and I'm not going to focus too much on these, you can look at these yourselves here, but basically, these are like all different courses. All courses are the same, but what they're looking for is that chemistry is not developed without biology or without physics, they're all developed together. The subjects are then also developed with the humanities. The geography people are involved in the science ones, the business are involved, the maths are involved. Everybody in terms of the IBs. The IBs got 3 different layers of curriculum development. There's the subject-specific people at the top, but they all work together. There's the education people with them. The teachers come in at the bottom, and in between they've got the universities people there, but everybody is involved to make a holistic program that suits all programs. Again, we're not going to spend too much time on this, but they're designing and modeling solutions to local and global problems. Effectively, this again is, and this will be the aims of every program. There's nothing different from this to every program that's being developed. What they're looking for is that the assessments can demonstrate knowledge of terminology, facts, and concepts. I always get a bit mystified when people think that knowing knowledge is a bad thing. You can't process knowledge without knowing knowledge in the first place. So everybody has to know something before they can actually use that word unpacking. I know it looks a bad word, but actually is unpacking of the knowledge is what the IB is really trying to do. But you have to know the knowledge in the first place. Understanding and applying it, analysing, evaluating and synthesising, experimental procedure, primary, secondary data, trends, pattern predictions, and having that in the context of the approach to teaching and learning. We're trying to have conceptual understanding. So they're going to have a syllabus, schema work that's built around a range of different contexts, suitable to the needs of students while making links between different areas of the subject. The practical nature is going to be emphasised by the inclusion of prescribed skills rather than prescribed practicals, which again, I think is moving towards that globally anyway. The skills can be applied across a wide range of activities and cover investigative skills and techniques common to chemistry at this level. They used to have options in the IB course, they've moved away from the options. One of the reasons was that the universities wanted standardisation. They sometimes felt that some of the options were easier than others, so they just wanted a standard course. And again, they listened to the universities for that. So they're going to put that into the core programme. This is what the science programme are going to look like now. It's not just chemistry, physics and biology. We've got 2 papers. There's a paper 1, which is multiple choice, without a calculator, by the way. Paper 2, and this database analysis. Paper 2 is short, and they are extended answers. There is an internal investigation. Owen's going to talk about that as well, which is, he'll explain how that works. This is the guide. Now, this is the current guide for chemistry. Owen was talking about numbers, and I wasn't aware of Owen's including force. This one only goes to 196 pages there for the chemistry one here now. And of 130 pages are spent on depth of treatment of the program. That's actually just for your aware there. So you get the essential question. This should not lead to a yes/no answer. The essential understanding. So this is the thing that's most comforting for me as a teacher. That I get limitations on where to stop. I get told what to teach. I'm told these are the things you need to know. That's what 130 pages of that guide are doing. Telling me what I should be teaching and also where I should stop. Because at that advanced level, or a lot of university level, you need to know where should you stop. Linking questions are provided to promote links between different areas of the course and encourage thinking beyond immediate content, as well as encourage problem solving. The next bit here is my colleague Hehir is going to speak to you about how the resources are available in biology. If anybody wants these guides and stuff like that, I can give them to them afterwards. Thank you.
Okay, I know we're in a hurry, so I'll try and be quick, but just to re-emphasise, Professor Anya Hyland really set the need for us all to be aware of what's available internationally so we can make our voice heard. And the survey done by the ISDA really showed our anxiety at what might become of the Leaving Cert, so we really have to be made aware. So Declan just asked me to share, well, what, as a biology teacher, what resources am I given to be able to teach the IB biology? So 2 main resources are available to every teacher. Number 1, the syllabus that William referred to. For biology, it's a 179-page document. It outlines all the key learning outcomes, where biology sits in sciences, nature of science, learning profiles, all of that. And then we have a website that we can go on to, and the website's packed full of resources that Owen will talk a little bit about, and I'll just refer to one part of that. If we look at the syllabus itself, and I just took one unit that would be common to both Leaving Cert and IB, ecology, for example, near the beginning we're told, well, that's going to take us about 12 hours to teach. We also have something called a Group 4 project that brings all science students together to do a collaborative project, and we're told let's spend about 10 hours on that. So each subject is indicated as to what length of time will be allocated. Then in the ecology, we can break that down into 4 main areas. And again, somewhere else on the MyIB website, it'll actually give us the hourly breakdown for each of those main topics. This is what one page of the syllabus would look like. So we start off looking at the nature of science. It places every topic within the nature of science, meaning is it showing data analysis? Is it showing serendipity? Is it showing observations? All of these things. Then each topic is given understandings, which I suppose are the learning outcomes or what we're expected, what a student is expected to know at the end of this unit. And they're very, very detailed in terms of exactly what's expected to be known. International mindedness, we're aware that we're not working in isolation, and scientists don't work in isolation. There's collaboration, there's effects of different ethnic backgrounds, etc., on our science knowledge. Utilization, where else in our syllabus might this topic cross-link to, and whereas to other subjects might it cross-link to. So that makes it handy for collaborating with other subject teachers. And then there's a specific number of aims that we have to develop certain skills in the science students. So the science aims, for example, can they use technology, etc., to explore a science concept, or can they handle big data and explain that? This is the same part of that unit of the syllabus. So as well as understandings, there's key applications and skills that Willie had referred to. So any particular skill or application that we need to develop within our students. And then guidance, if they feel that something wasn't quite clear, particularly in the change of syllabus, if something has changed, that's made more evident under the guidance heading. So, and that's the same for every subtopic within the syllabus. So the big question is, does this syllabus meet our needs? And if we look at the syllabus statement, chemical energy and carbon compounds flows through food chains by means of feeding. That is an exam question that came up last summer. So does that statement prepare the students to be able to answer that question? I think clearly it does. Another syllabus statement, we're not going to spend time reading it through, we're short of time, but again, we can link the statement from the syllabus to the assessment in the exam. There's a very clear link. There's no student should be surprised by that type of question. Again, a different type of question, a more open-ended question, but again, directly linked to what we were told the student had to know. And then a data analysis question, but again, no big surprise for the student who was well prepared from the syllabus. So does it meet the needs? Yes, it certainly does, and far more so than what the NCCA is telling us that may be ahead of us, I would think. The other thing that's available to everybody is the MyIB website. Lots on it, and Owen will explain, but one of the things I use a lot is the Teachers Forum. I know we have a Teachers Forum on the ISTA website, but really people aren't using it, and I don't know why. The MyIB website, it's populated daily with questions, with answers. As a teacher, I can go on there, ask a question for a resource or something I'm not sure about, and I will get an answer. There's 2 people appointed by IB to moderate the whole website, but we get teachers coming in from all over the world with their ideas, with their answers as well. I'll skip over that because Owen, you're going into that, aren't you? Okay, so teacher support material, plenty of textbooks, but that's not our problem in Ireland. We have plenty of textbooks as well, but they are there. And then there's another one that's not freely available to all teachers, but it is recognised by the IB, but it is a subscription thing. But again, like StudyClicks, but we can go in topic by topic and get all the past exam questions. Group 4 is that 10-hour collaborative project, physics, chemistry, maths, working away together as a 10-hour practical-based work. And again, resources are available for that within the syllabus and on the My IB website, and on the forum again, pop in, ask a question, you'll get your answers. Okay, go on.
I suppose the slight difference that the IB program will have is that there is an element of an internal assessment work that's going to be involved in it. So the kind of the general rationale in terms of having an internal assessment is that it allows students to express themselves beyond a time frame that's set outside by an exam. It's taught as part of the overall 60 hours at higher level on the course. So it's skills they would have learned throughout the course of the 2-year program. The assessment criteria is both the same for standard level and higher level students. And one of the key things that has about it is that students are actually encouraged to seek information from teachers from it. So if you take the new junior cycle, they can be quite penalised for looking for guidance towards it. So what will an IA actually look like? So it's generally between a kind of a 6 and 12 page piece of work. Normally students will head towards the 12 page. They can put an appendix after it, but 12 pages is kind of the limit that they will look at. And complexity wise, it should be similar to what they're expected from the course. It's not expected to be university standard, so it is a level that they should be able to attain. But they do have to show some initiative in how they create their experiment and their individual research question. And they can use any sort of method that they really want to get it. So the vast majority will go for a practical lab-based experiment. They can use modelling activity using a spreadsheet analysis of data taken from a database, or investigate an open-ended simulation. But most of them do tend to go for the practical-based experiment. It's assessed under the 4 categories. William talked a little bit about some of them. The one it's kind of solely assessed on the course is about the demonstration of appropriate research, experimental and personal skills necessary to carry out insightful and ethical investigations. So on the paper at the moment, there is a section where there is 10 mandatory experiments in physics that you're required to do as part of your 60 hours. Outside of that, you can decide on what program you want to set out on your own. But you will get a question dealing with data on those 10 set experiments as well. Just to give you a kind of an idea, I looked at a couple of my previous IA titles. Some of them are quite straightforward in terms of, how does temperature affect surface tension? How does the angle of a wing on a plane affect downforce? How does the height an object falls impact on the crater size it produces? Surface area and how much weight a glue tack can hold. Periodic time of torsion of pendulum, depending on where you put the weights on the arm of it. Does counterweight mass of a catapult affect how far it goes? So they set out a question. Some of the answers will be available online. How it's then going to be assessed. So there's a personal engagement part on it. So it assesses to the extent to which they engage with the exploration, how they set out, how they look about a personal interest in it. Some of the students get hung up on it, and they kind of have to think they have to have a real personal interest. A lot of this one is actually how do they approach? Do they develop a set of instructions or design an experiment that's for themselves? That's not something that they've taken off the shelf from another book. You then have your exploration. So this kind of looks about have they done background research? Have they looked at designing a method that allows them to collect data in a safe and environmentally and ethical considerations to take on board? Analysis, when they collect their data, have they collected enough data? Have they processed the data? Have they looked at their research question that have the beginning of it? Does the data allow them to answer it? Evaluation then is when they take that data and they look back and see, well, how does that link to what their research question is? Does it prove it? Does it not? Where were there any weaknesses in their investigation? What they could do to improve it? And then there's marks then for communication in terms of how do they set out the report? Is it done in a suitable sort of way? The IA mark consists of 20% of their final result. And I've just taken percentage there. I've just taken the grade boundaries for last year's paper. So IB works on a slightly different. 7 is the top boundary and it works its way down. So if you scored between 20 and 24 on your internal assessment, that was deemed to be in the 7 category, in the top category. I suppose one of the things that was mentioned was about having an internal assessment part on it. Yes, we mark the work for the students, but we don't have a final say on actually what their grade is. So the students' work is marked by teachers in school, and then typically a sample of 5 students from your class or from your subject group. So I teach physics, so it's just more on myself. Hillary, there's another biology teacher with Hillary. So what they would have to do is they would have to sit down with each other. They'd have to moderate their own work, so it's a similar standard, and a sample of 5 from that biology work is sent to the IB. And then what happens is your results will move based on that sample of 5. So the IB has the final say in terms of what you're marking at. And you're not really left alone on it, is that you get a report back from your moderator. Typically, if your results are outside of their tolerance, they'll actually give you a written report and they'll say, this aspect, you were a little bit lenient on it, you could change this. So you are given guidance in terms for future progress. Hillary spoke a little bit about material from my IB, so I'll quickly run through parts of it. So it gives a huge quantity of information. It gives schemes of work, time allocated for subtopics, and it's designed to support experienced and inexperienced teachers. So how to organise practical work, and it's a complement to the IB professional development. And then I just took the part on the assessment side, so it gives assessment papers, gives subject reports, gives guidelines in terms for how you would set your descriptors. And then I just went into one of these sections from my IB, and this just then gives you the grade descriptors for each of the assessments. So I took 5 to 6 in terms for their analysis work, and it gives you an assessment on how that's supposed to be worked, and it gives you a brief breakdown. Also on the my IB, it gives you sample work. So it gives you sample student work, it gives you a sample work that's been annotated by a teacher, and then it also gives you examiner's comments that go with it. So this is the sample that I took from the my IB, where this is the marked work from a teacher. So this is what the teacher sent into IB to be moderated, and what they've done is they've explained why they've assessed it in this way, why they've assigned these many marks from it, and they've just highlighted, and this is what the moderator will receive. And then this is the report. Then the moderator has then awarded the same mark as the person who's corrected it, and they've given a reason why. And I picked the personal engagement one because they talked about, interest in it doesn't really enhance the research question. So it's not enough to say I'm really interested in photography, so therefore that's a personal engagement. It's not enough. Other thing that we also get then is we would get a subject report. So within each of the time zones from the subject report, there's a detail in it. So I just took a section from the subject report, and again, that's just, it's on that year. It tells guidance towards teachers about what went well from the whole students of that year group, and what could be done to improve it. And then recommendations for future candidates. So every time zone, in terms of exams, because they're done in multiple time zones, gets a report like this. Every year we get a report like this. And then as Hillary done, I grabbed one of this. This is it says it's 14 hours. There's 3 topics, subtopics within this. This is just the physics one. If you go into the MyLB, the guidelines for this is 5 hours. So, and again, Hillary's gone through. It gives you the understanding that they're expected to know, where you have your international mindedness, and then the applications and skills gives you the detail of what's expected. And then I just quickly grabbed 2 exam questions based off those. So one for